So we're going to go ahead and get started here. I want you guys to have plenty of time to work. So for a lot of us, this is going to be review, right? But it'll be good review because, like I said earlier today, we're setting our foundation today, okay? You can't just start building a house on straight up dirt. You got to dig out the dirt, lay some cement, get a nice solid foundation so that your house doesn't, fall down, especially in like an earthquake or something like that. So we're going to start with the basics. This might be a little simple for some of us, but it'll be a good review. So our goal, anytime we're solving an equation, our goal is to get our variable isolated. What does it mean for something to be isolated? By itself. Exactly. By itself. We want our variable all alone on one side of the equal sign. Typically, we want it on the left side of our equal sign so that it reads x equals blank from left to right. But the beautiful thing about an equal sign is that it goes both ways. It doesn't matter what side our x is on technically. We just typically like to have it on the left because, in America we read things from left to right. But in reality, it doesn't matter. The way that we're going to accomplish this is by using inverse operations. What's another word for inverse? Anyone got a synonym for inverse? It's another word for inverse. Starts with an O. Opposite, right? So whatever operation we're doing to our variable, we just have to do the opposite or the inverse. So if we have addition, what would the inverse operation be? Subtraction. Exactly. So if we have an equation that says x plus 4 equals 6, plus 4 means we're adding. What we want to do is subtract 4 from both sides. What if we're multiplying? What's the opposite or inverse of multiplication? Division. Exactly. I hate this division sign, but it's hard to make a little fraction. And again, these go both ways. The inverse of addition is subtraction. The inverse of subtraction is addition. The inverse of multiplication is division. And the inverse of division is what? Multiplication. Exactly. What we don't want to do is cross these, right? If we see that we're adding something to x, we don't divide. Exactly. We keep it addition and subtraction. Those are inverses. And multiplication and division. Those are inverses with each other. We always want to make sure to apply the inverse operation to both sides. It's key. Okay, I'm going to pause right there so we can catch up. Take a look around and see how we're doing. So, you got to ask yourself this one question. When you start out solving an equation, now, you're not always going to need to ask yourself this, because the more we do it, the more comfortable you'll get. You'll start to see the patterns and kind of just know what to do. But starting out, you're going to ask yourself, what are we doing to our variable? Because whatever operation, whether it be addition, subtraction, multiplication, or division, whatever operation you're currently doing, you have to do the inverse operation in order to solve. I know that's a lot of writing, so I'll give you guys a little bit of time to get that written down. Yep.
I'll do this one.
That one's just like this.
Yeah, but I don't understand all that.
It's like near the table. Right? You have to do the change, the little arrows, remember? If you have a graph, you got to do rise over rise, like that.
Alright.
Yeah. Give it your best shot. Let's take a look at our first example. Let's say we've got x plus 4 equals 7. We're going to ask ourselves, what are we doing to our variable? If you look just at the left side, x plus 4, what are we doing to x? Are we adding to x? Are we subtracting to x? What are we doing?
Adding.
We're adding. We are adding 4 to x. Thank you, sir. We are adding 4 to x. What would the inverse of adding 4 be? What's the opposite of adding?
Subtracting.
Subtracting. So because we're adding 4 to x, we can say, so let's subtract 4 from both sides. We can think of an equation kind of like a scale, right? Not like a digital scale that you just step on, an old school scale where you have to balance things on the left and the right side, right? Everything has to be balanced. So if we have our equation, x plus 4 equals 7, just like we said in the warm-up, we want to split our equation down the equal sign. This is something we should do first every single equation we see throughout this entire unit, first thing you need to do is split your equal sign with a vertical line just like that. Like I said, these equations that we're starting out with are going to be really simple, but we're going to build them up to be somewhat complicated. So we want to make sure we know what the left side of my equation is and what the right side of my equation is. All right? On the left side of my equation, we have x plus 4. We've already determined that the inverse operation of adding 4 is subtracting 4. So right underneath this plus 4, we're going to write that inverse operation minus 4. We don't just do that to the left. We also have to do it to the right. And we'll subtract 4 from 7 as well. I'm going to draw a line under this to signify that we are altering our equation in a way. On the left side, what is 4 minus 4? What happens with those two numbers? They cancel out. We can cross them out, leaving us just with x. Yeah, sure. Leaving us just with x on the left. And what does 7 minus 4 give us on the right? 3. 7 minus 4 gives me 3. So my answer here is x is equal to 3. Now again, some of you may look at that and go, well, I can just figure that out. Blank plus 4 equals 7. Duh, x has got to be 3. But like I said, we're going to build these equations out. They're going to get a lot more complicated. So we really have to get comfortable with this process, right? Step by step, even if it's just one step like we had here, we got to show our work. So when we get to equations that look like this, right? There's a lot going on here. It's not as simple as just, oh, x is obviously going to be 3. Right? We're going to have to know what these... Are you okay?
Yeah, I'm fine.
We got to know what these steps are to break something like this down step by step. Something like this. Right? You can't just look at that and go, oh, duh, x is equal to 4. It's going to get a little complicated. That's why we're starting off easy and working our way up. I don't show you that to scare you. I show you that to emphasize the fact that we have to develop a solid foundation first. Because if you can't get this, it's going to be really hard to get the stuff I just showed you, all right? But you will. You will. All right, let's take a look at another example. We know the opposite of addition is subtraction. We've got that down. Let's say we've got 2x equals 12. What are we doing to x here? We're multiplying x times 2. If we're multiplying x by 2, we want to get x by ourselves. That's our goal. What's the opposite of multiplying?
Divide.
What's the opposite of multiplying, everybody?
Subtract.
Subtract.
Oh, division.
Take a look back up. Multiplication is an inverse with division. So if we are multiplying x by 2, let's divide both sides by 2. Again, we're going to split our equation with a vertical line through the equal sign, just like that. Come on, Ari, stay with us, please. We're multiplying x by 2. The opposite of that would be to divide both sides by 2. Not just the left side. We've got to divide the right side as well. We've got to keep this equation nice and balanced. In order to do that, we have to do the same thing on the left that we do on the right. Roz? Yeah, when Ho comes back. And then we simplify. What happens when we have 2 divided by 2? What does that equal to? 1. So we could just cancel those out. Right? Leaving us with x is equal to, what's 12 divided by 2? Ooh, what's 12 divided by 2?
24.
That would be 12 times 2.
12 divided by
2 goes into 12 6 times. 12 over 2 gives us 6. There's our answer. X is equal to 6.
I thought you said times. I was like 24.
That's okay. This is why we have to be very careful about what the operation that we're doing is. Because if we mess it up, we get something very different. Right? You got this written down? Okay. Let's do another example. Let's say we've got x over 2 equals 5. X over 2 equals 5. What operation are we doing to x here? We're dividing. We are dividing x by 2. What would the opposite of dividing by 2 be? Multiplying by 2. So because we're dividing x by 2, let's multiply both sides by 2. I'm going to split my equal sign down the middle. I'm going to multiply the left side by 2. And I'm going to multiply the right side by 2. It looks just like that. So we're not writing it directly underneath, because we've got a fraction here and we want to cancel those 2's out. So we write it like that. Take a look. What happens with these 2's here? We've got a 2x over 2. What can we do with those 2's? Well, what happened in the previous example when we had 2 over 2? We cross them out. Leaving us with just x equals, what's 5 times 2? 10. Boom. There's our answer. X is equal to 10. And it makes sense, right? If we took 10, plugged it back in for x, 10 over 2, that just gives us 5. Not right now. L. Questions I could answer about any of those examples real quick? Give me a thumbs up if this is making a little bit of sense. Good. Good. Okay. Let's take it up a small notch. Make sure I'm on the right page. There we go. With the example, 3x minus 1 equals 5. So all those previous examples, those are all technically one-step equations, right? We had to either subtract, we multiplied, we divided. Now this is a two-step equation, which again should be familiar from Math 7. Hopefully we remember. No? That's all right. That's why we're going over it right now. What's the first thing I want to do here? Before that.
Oh, the line.
Exactly. We want to split our equation in two sides. Now there's two things we're doing to x here. What's one thing that we're doing to x? We're multiplying by what? 3. And then we're also doing what? Subtracting it by 1. So what we're going to kind of do here, put this in the side, is reverse PEMDAS. What's the last thing that you want to worry about with PEMDAS? Well, the first thing you want to worry about is parentheses. Then you want to worry about exponents. Then multiplication and division. What's the last thing you worry about?
Subtraction.
Adding and subtracting. So we're going to flip it around. Would be what? SADMEP, if we flipped it around. We're going to worry about addition and subtraction first.
SADMEP. SADMEP.
SADMEP, yep.
Yep.
It's not as catchy as PEMDAS, but that's okay.
SADMEP.
We're going to worry about addition and subtraction first. We see we've got some subtraction here. What would the inverse of subtraction be? What would the inverse of subtraction be?
Adding.
Adding. So, if we're subtracting by 1, the inverse of that would be to add 1 to both sides. What is negative 1 plus 1?
1. Oh, wait, no. Wait.
0.
0, so we can cross them out. What is 5 plus 1? 6. Rosbro, can stay with us, please. We've got 3x equals 6 now, right? 5 plus 1 gives us 6. We bring that 3x right down. Now that we've got rid of our addition and subtraction, we've got to worry about our multiplication and division. We see that we're multiplying x by 3. What would the inverse of multiplying be? Dividing. Divide the left by 3. We divide the right by 3. 3 over 3 cancels out, leaving us with x. And 6 divided by 3 gives me what? 2. Boom. There's our answer. So 2 different steps. Still using inverse operations. Going in the reverse order of PEMDAS. reverse PEMDAS doesn't make sense, I kind of think of it like an onion, right? If X is the center of our onion, we got to peel off all these layers around it to get it all by itself. The outermost layer is this -1 because 3 is right there next to X. So we can't get to that 3 until we get rid of that -1. Does that make sense? Okay. That's what we get. X is equal to 2. We'll do one last example and then we'll get started. And then I'll get you your stars. Do x over 2 plus 4 equals 14. What are the two things we're doing to x right here?
Adding and multiplying.
Adding and multiplying.
Dividing.
Dividing, right? We're adding and we're dividing. If we're going to go reverse PEMDAS, which of those do we want to get rid of first? The adding or the dividing?
Adding.
No.
The adding. We want to peel this outer layer off first before we get to that inner layer underneath the x. So if we're adding 4, what's the inverse of adding 4? Subtracting 4 from both sides.
Cross this one out.
Cross out the 4's on the left, leaving us with x over 2 equals 14 minus 4, 10. There's our first layer peeled back. Now we got to get rid of this inner layer. We're dividing x by 2. What's the inverse of dividing? Multiplying. So we'll multiply both sides by 2. Two over 2 cancels out, leaving us with x, absolutely. And 10 times 2 on the right gives me 20. Not too bad, right? Hopefully. All right.